So far this year, the weather has been absolutely relentless. We have had violent tornado outbreaks tearing through communities across the plains and the south. We have had historic late-season blizzards burying the upper Midwest under feet of snow in the middle of May. We have had record-shattering heat domes baking the desert southwest with temperatures that belong in July, not March. We have had frost events wiping out cherry orchards and vineyards that were weeks ahead of schedule because the warmth came too early and the cold refused to leave. And I know a lot of you, myself included, have been sitting back wondering when this atmosphere is finally going to take a breath and give us all a break. Well, I hate to be the one to tell you this, but the answer to that question is not anytime soon. Because everything that has happened so far in 2026, as wild and as exhausting as it has actually been building towards something. The pattern that has been driving all of this extreme weather is not random. It is not just bad luck. It is part of a much larger atmospheric setup that is now reaching a critical threshold, and what comes next has the potential to be the single biggest and most consequential weather event of the entire year. And in this video, I'm going to explain exactly what that means, why it is happening, and most importantly, what you can do to prepare for it. Before I get into what is coming, I want to make sure everyone understands the foundation of why our weather has been so extreme in the first place. Because once you understand the mechanism, everything else starts to make a lot more sense. The driver behind the chaos we have been experiencing is something called the jet stream, and specifically the way the jet stream has been behaving in a deeply amplified and volatile pattern throughout all of 2026. The jet stream is essentially the river of fast-moving air high up in the atmosphere that separates cold polar air from warm tropical air and steers our weather systems from west to east across the country. In a normal year, the jet stream runs in a relatively smooth and progressive pattern that keeps weather systems moving through fairly quickly without getting stuck in one place for too long. But when the jet stream becomes highly amplified, when it starts developing these enormous dips and ridges that dig way further north and south than normal, that is when you get the extreme events. Deep troughs dragging Arctic air all the way down into Texas in February, massive ridges pumping desert heat into the Pacific Northwest in June, powerful blocking patterns that lock a storm system in place over one region for days at a time and just keep hammering it. That amplified jet stream pattern is what we have been living through in 2026, and the reason it has been so persistent and so extreme comes down to something much bigger that is happening in the ocean right now. I know some of you are probably already thinking about this because we have been talking around it for months, but it is now time to address it directly. The sea surface temperatures in the equatorial Pacific Ocean have been running significantly above normal for an extended period, and the latest data from the Climate Prediction Center has crossed a threshold that changes the entire seasonal forecast picture for the rest of 2026 and into 2027. We are now in the early stages of what is shaping up to be one of the most powerful El Niño events in recent decades, and some of the atmospheric scientists who spend their entire careers tracking this stuff are using a word to describe what is developing that they do not use very often. They are calling it a super El Niño. And before I explain what that means, I want to give you the basic framework for understanding what El Niño actually is, because I think a lot of people have heard the term thrown around without ever really understanding what it does or why it matters for the weather in their specific backyard. Every few years, the tropical Pacific Ocean goes through a natural cycle of warming and cooling that has enormous ripple effects on weather patterns all over the world. We call the cool phase La Niña and the warm phase El Niño. And together, the cycle is called the El Niño Southern Oscillation, or ENSO for short. For the past 3 years, we have been locked in an unusually persistent La Niña, which is actually pretty rare, because a typical La Niña only lasts about 9 to 12 months. 3 years of La Niña is long, and the atmosphere has been loaded like a spring under that pattern. Now here is the key to understanding why the shift to El Niño is such a big deal. Under normal conditions, the trade winds near the equator blow strongly from east to west across the Pacific. Those trade winds push warm surface water away from South America and allow cold water from deep beneath the ocean to rise up and keep the eastern Pacific relatively cool. That cold water suppresses thunderstorm development in the central Pacific and keeps the jet stream in a certain configuration. But when the trade winds start to weaken, which is exactly what happens at the beginning of an El Niño, all of that warm water that was being pushed westward sloshes back toward South America and spreads across the central and eastern equatorial Pacific. You get an enormous pool of abnormally warm ocean water sitting in the middle of the biggest body of water on the entire planet. And that warm water starts fueling massive clusters of intense thunderstorms right in the middle of the Pacific, where they would not normally exist. Those thunderstorms generate so much heat and so much energy that they literally bend and redirect the jet stream. And when the jet stream shifts, everything downstream shifts with it. Your weather, my weather, the weather across every region of the United States, All of it gets reorganized based on what is happening in that patch of ocean thousands of miles away. That is how powerful this thing is, and that is why a super El Nino developing right now in the summer and fall of 2026 is something every single person watching this needs to understand. Not ready institutionally, emergency management systems are calibrated to probabilistic expectations. Resources are prepositioned based on forecast ranges. Evacuation orders are issued according to protocols developed around historical intensification rates and historical lead times. When a storm behaves outside historical parameters, when it intensifies faster than the system anticipated, when the forecast track compresses the warning window from days to hours, the institutional machinery struggles to keep pace. Evacuation orders that should have gone out earlier couldn't go out earlier because the storm hadn't yet revealed what it was becoming. Shelter preparations were sized for the storm on the previous advisory, not the storm on the updated one. Resource preposition decisions were made before the rapid intensification event rewrote the threat picture. None of the people involved made bad decisions with the information they had. The information they had was wrong. And it was wrong because the storm exceeded the model, and the model was calibrated to a baseline that this storm wasn't operating from. The moment it turned is the moment that deserves the most scrutiny. Not the moment landfall occurred, not the moment the eye wall made contact with the first populated area. The moment before. The moment in the data record where the intensification rate bent sharply upward, where the pressure drop accelerated, where the wind speed curve went from gradual to steep. That moment represents the failure point of the entire predictive chain. Every warning, every evacuation order, every resource decision downstream of that moment was built on forecast confidence that the storm itself was in the process of invalidating. And the communities sitting in that downstream window were left holding the gap between what the forecast told them and what the storm actually delivered. That gap is measured in preparation that didn't happen, in reinforcements that weren't made, in evacuations that didn't complete, in people who made decisions based on one storm and experienced a different one. This is the human cost of forecast-busting intensification events. Not just the physical destruction, which is extensive and real and measurable in the immediate aftermath, but the deeper cost, the decisions made on incomplete information, the preparations calibrated to the wrong threat level, the entire chain of human choices that a warning system sets in motion, and that a faster-than-expected storm renders inadequate before the first gust arrives. The recovery will begin when the winds drop. Emergency teams will move in. Damage assessments will be conducted. Federal disaster declarations will be requested. The machinery of response will activate and deliver real assistance and real relief. People are resilient. Communities endure things that seem unsurvivable and find a way through. But recovery after events like this one carries a burden that the headlines miss. It isn't just rebuilding what was destroyed. It's rebuilding while knowing the next event is coming. While the clock is already running on the window between this storm and the one after it. While the budget allocated to recovery is the same budget that should have been allocated to hardening. While the political attention that briefly focuses on these communities in the aftermath of disaster is already drifting toward the next news cycle. While every repair, every patch, every temporary fix becomes the foundation for the next round of damage because there isn't enough time or money or political will to do the work that would actually matter. Building to a standard that accounts for what the climate is now delivering, not what it delivered in the past. What this storm adds to the record is not just a data point about wind speed or central pressure or storm surge height. It adds a case study in the consequences of operating with outdated assumptions. Every aspect of the failure cascade here, the compressed warning lead time, the structural damage that exceeded design specifications, the recovery deficit already in place before the storm arrived, the institutional machinery responding to a previous version of the threat connects back to the same root. The world these systems were built for is not the world they are operating in. The ocean is hotter. The rapid intensification events are more frequent and more extreme. The seasons are longer. The recovery windows are shorter. And the gap between the climate the models were calibrated to and the climate delivering the actual events is widening with every passing year. Closing that gap requires more than better forecasting, though better forecasting helps. More than improved building codes, though updated codes matter. More than additional recovery funding, though funding is essential. It requires a fundamental recalibration of the assumptions embedded in every layer of the system. The storm models, the risk assessments, the infrastructure standards, the insurance frameworks, the institutional protocols, all of them were built around a baseline. The baseline has shifted. Everything downstream of it needs to shift with it, or we will keep arriving at the same moment this community just lived through, watching the radar, watching the numbers change, watching the gap open between what was predicted and what arrived, watching a storm become a monster in the window between the last advisory and the next one, and finding, again, that nobody was ready. The storm will pass. The data will be analyzed. The reports will be written. The forecasters will study the intensification sequence and refine the models. The engineers will assess the damage and update the load calculations. The emergency managers will review the timeline and revise the protocols. All of that work is real and necessary and genuinely improves the system's capacity to handle the next event. But the next event is already forming somewhere over water that is warmer than it should be, in a month that used to be quiet, under atmospheric conditions that are increasingly favorable in seasons that the old calendars called off-peak. And when it turns, when the pressure drops faster than the models expect, and the winds jump past the previous forecast ceiling, and the warning window compresses, and the communities in its path are making decisions based on information that the storm itself is already invalidating, the question will be the same one it always is. Why wasn't anyone ready? The answer will be the same one it always is. Because ready means something different now, and we haven't finished redefining it yet.